Determine by inspection whether each system of equations has only one solution, no solution, or infinitely many solutions. Number 1, they're both already written in the same format. For number 2, I'm going to multiply by 3 so we can compare the x and y terms here. 3 times y is 3y, 3 times 3x is 9x, and 3 times 5 is 15. So if the equations are identical, is that an infinite solution or a no solution? In number 3, they match. In number 4, I'm going to multiply by 6 so that the y terms match. 6 times negative 2 is negative 12, and negative 12 divided by 3 is negative 4. 6 times 7 is 42. For number 5, I'm going to move the x term over. So that gives me 4y equals negative 3x plus 2. Since the x terms do not match, this is going to be a one solution. Because if I divide by 4, this would give me a slope of negative 3/4. And if I divide by 4 here, that would give me a slope of positive 3/4. So this is a one solution system. This is a digital lesson with a video on the teacher slides. So we'll start here. So we're starting with some aspects of weights here to get us set up. It says, can you balance a scale using all of the available swallows and sparrows? So 2 swallows is the weight of 1 sparrow. Based on your balance, what is a possible weight for 1 swallow and 1 sparrow in grams? There are plenty of different possible weights, but as long as the swallows are half the weight of a sparrow, or you could phrase it as a sparrow is twice as heavy as a swallow, we're going to balance these scales. So you might use something like 10 for the swallow and 20 for the sparrow, because 2 10s make a 20. You could use 15 and 30, 11 and 22. This scale has a 1 jin weight attached. A jin is an ancient Chinese unit of weight. Can you balance the scale using the swallows and sparrows? Do you have enough information to determine the weight of 1 swallow and 1 sparrow in jin? And how can you determine the weights? So I have here an unbalanced scale. But if I put 15 swallows on there, I get the weight of 1 jin. So can I balance the scales using swallows and sparrows? Yes. Do you have enough information to determine the weight of 1 swallow and 1 sparrow in jin? Well, yes. We see that it takes 15 swallows to equal 1 gin. So that means that each swallow is 1/15 of a gin. We also know that the sparrows can take the place of 2 swallows. So 2 1/15 is 2/15. Now we don't have a conversion between gin and grams or ounces or pounds, but we can determine how much of a gin each of these birds weigh. Use a system of equations to find the weight of each type of bird. Start by defining your variables for this situation and make sure to use gin as your unit. The swallow has been done for you, so we're going to just copy and paste down here for the swallow. And then we're going to change the sparrow. So we need a different variable because it's a different bird. And instead of a swallow, this should say a sparrow. Now write an equation to represent each balance. Well, I have 2 swallows is equal to 1 sparrow. In this one, I have 13 swallows and 1 sparrow is equal to 1 gin. I don't necessarily need this one here. I can just write a single y. All right, so now it says, how much does a swallow weigh in gin? How much does a sparrow weigh in gin? We can use substitution. Since this is y, we can replace 2x in the y position. So we'll have 13x plus 2x equals 1. 13 plus 2 is 15x. Then divide both sides by 15. And you see we get 1/15 4x. Then we'll plug it back in to the original equation. 2 times 1/15 equals y. Well, 2 times 1/15 is 2/15, just like we said earlier. Well, apparently the try it feature is not working for me. All right, so livestock was commonly traded in ancient China. Try trading an ox. We're relating this back to the video we watched at the beginning. It says, in this trade, 1 sheep and 3 liang of silver are traded for 1 ox. What are some possible values for 1 ox and 1 sheep in liang of silver? Well, if an ox was worth, let's say, 8 silver, then the sheep would have to be worth 5, because 5 plus the 3 that we already had would equal 8. It says, how did you determine the values? Are these the only possible values? Explain. We do not know how much the ox is worth. If we did know how much the ox would worth, we could work backwards to figure out how much the sheep was worth. Choose how many oxen and sheep you would like to trade, and then click trade. I would like to trade 2 oxen and 1 sheep. That is 18 coins or 18 liang. Earlier you said oxen were worth 8 and the sheep were worth 5 liang. Based on your new trade, are your values still possible? Explain. Well, let's see. 1 sheep would be 5, and 2 sheep or 2 oxen would be 16. Well, 16 plus 5 does not equal 18. So no, those are not possible values. Two sets of 8 plus 1, 5 for the sheep. That would be 16 plus 5, which is 21. And that is not equal to 18 Liang silver coins. Use a system of equations to find how much each animal is worth. Start by defining variables for this situation. Make sure to use Liang of silver as your unit. So we're going to say X for oxen and coins of silver. And then for the sheep, we'll use maybe Y. Okay, so write an equation to represent each trade. So 1 ox is equal to 1 sheep plus 3 coins. And the other one, 2 oxen plus 1 sheep was equal to 18 coins. We can use substitution method for this one as well. We're replacing x with y plus 3. So this will say 2 times y plus 3, plus y equals 18. 2 times y is 2y, 2 times 3 is 6, 2y plus y is 3y. Subtract the 6 from both sides. We end up with 3y equals 12. Divide by 3 and we get y equals 4. So that is the sheep. And we need to plug it back in. X equals y, which is 4, plus 3. So x equals 7. The ox is 7 and the sheep is 4. And it says great. The problem you solved is based on a problem from an ancient Chinese math text titled 9 Chapters on the Mathematical Art. Here is an English translation of that problem. Now there are 5 cattle and 2 sheep costing 10 liang of silver. 2 cattle and 5 sheep cost 8 liang of silver. Tell, what is the cost of the cow and the sheep respectively? Make a picture to represent the situation. So that first one would show 5 of the cattle and 2 of the sheep would be 10 silver. Then in the second problem, or the second equation, we would have 2 cattle and 5 sheep, and that costs 8. You could set up a system of equations that would be 5x plus 2y equals 10, and 2x plus 5y equals 8, and then use elimination to solve this type of system. But all it asks us to do is make a picture. So that is the end of lesson 12.